My name is Carl Ballack. I'm from a company called PQRS. We are going to take a look at your installation and what you guys are doing and what it is you need to look at if you are interested in getting a solar system for your factory. The demand charge at your factory and the ridiculous rates that you guys are paying. So there's definitely scope for reducing your costs by using a solar system, but there are a couple of things you need to be aware of, and I created this video so that I can quickly guide you through the steps without necessarily spending an hour at your factory or in your offices trying to explain the whole process. What I did was I have taken your login details for your metering company. I've had a look at your load profile, and what I've got on the board over here is what I consider should be your approach for the solar system. First of all, solar is not going to necessarily reduce your demand. Maybe we should just cover these items quickly, and then I can go into them in a bit more detail. So solar is not necessarily going to cover your demand because solar has an impact on the kilowatt hours at your factory and not necessarily the reactive power. Now, your power factor at your factory is 0.9. I took the information from your metering portal. I downloaded it, and I have looked at your reactive power component because the reactive power doesn't change when you have a solar system fitted. The reactive power is a component that is created by your loads on your premises. The worst reactive power component that I've found, even though you guys are charged if you look at your bill, you've got a power factor of 0.9 or 0.94, 0.93. It's very impressive. But if you go through your installation, you'll see that over weekends that power factor can go down. I think the worst I saw was 0.67. This is going to negatively affect your installation. So before we look at that in detail, let's just quickly run through the next. So an EMS is an energy management system, or what you want out of an EMS for your particular factory is you want an EMS that can understand where your furnaces are in temperature, know which furnace to switch on and off, understand what the ambient temperature is, how that affects the cooling down rate of your furnaces, understand where you are as far as productivity is concerned, which process should be stepped up to priority and that kind of thing. And this EMS is not going to be able to do that. The EMS that you've been quoted for, if you buy it as a loose standing product, is about $7,000. This EMS is not complex enough to understand what's happening in your factory and to compensate for different scenarios. So you're going to end up with a product that's not going to do what you want it to do, or not going to do what it should be doing to the level at which your factory is operating. Battery cell capacity, the batteries that you have been quoted for, has a 0.5 C rating. Now, what this means is when you buy a 100 kilowatt hour battery pack and it has a 0.5 C rating, it means that the amount of power that you can draw out of that battery pack is equal to 0.5 times the capacity of the battery pack, which equals 50 kilowatts. So in order for you to draw 400 kilowatts or 500 kilowatts out of your batteries, you're going to have an 800 kilowatt hour battery pack. Instead of that, you could rather opt for a 1C battery, and then you would be able to draw 100 kilowatt out of a 100 kilowatt hour battery pack. So you need a battery that has a higher C rating. The commissioning. I know guys say that solar systems are installed and commissioned 6 to 8 weeks. And in your case, you would be able to have a 300 to 400 kilowatt solar system installed and kind of working in 6 to 8 weeks. The commissioning is the problem over here. You guys are working 7 days a week. My experience on commissioning of solar installations is that the commissioning process in industrial commercial environments could easily take 6 months, 6 to 12 months. even though the installation itself only took 6 to 8 weeks. And where the 6 to 8 months comes in is in tweaking variables in your installation. So you do the solar installation, and when it gets to the commissioning, you set up everything. You set up the EMS. So the process is that when there's load shedding, the EMS should start up the generator, but for some reason it doesn't start it up. So now the process begins where you have to fault find and understand why the EMS is not starting up the genset. That usually involves the supplier. So now you have the tech staff coming out to fault find installations. It is really onerous, and it could take upwards of 6 months to commission an installation at a site like yours. Commissioning for me, if I look at commissioning and with what you guys do, the only thing I see is risk. Your solar approach, I feel, should be a 3-step approach. One is you should get a controller first. You should get a controller that can take some of the information. So it is possible to get a controller that can read the data from the SCADA system, and that can use that data to switch loads on and off. That's the one option. The other option is fit sensors everywhere and fit devices so that you can switch some of the furnaces on and off automatically using the controller. You would be able to bring down your demand purely just by managing the variability in switching furnaces, and for the controller to manage those ratios for where the furnace has to be in temperature and where the rest of the factory is in the various processes. The first step is you're going to have to get the controller in to work with what your factory does, and to get and to be aligned with the processes and the various steps. This is going to include monitoring and measuring your power factor and your harmonic component. I'm almost convinced you have some sort of harmonic component. You'll see over weekends specifically, your power factor drops substantially or significantly as a ratio to what is on or what is running at the time. Now, when you have a solar system, the solar is not going to take the reactive component away. So you want to kind of sort out the reactive component in this process. If you do step 1 first, you sort out any issues on the control as a controlled in a controlled environment. In other words, you're doing one process and you're sorting out one process. Then the next would be to have a grid-tied solar system fitted, because the grid-tied solar system is going to tie into the control. But now you would have already had the control system sorted. So the control would be running your factory, and you would simply bolt on the grid tie system into your existing supply sources of supply. It's going to be much easier to fault find. It's going to be a smoother ride, and you won't be frustrated with the process because that part would function already. And the only thing that can then be tweaked would be the grid-tied system itself. Not going to affect your operations at all. And then the last thing that you'll do is you'll fit a battery. So the grid-tied system is going to bring down your kilowatt hours, and the batteries will support your demand. You can do these two together, but I would not recommend that you do all of them at the same time. There are too many variables and there are too many things that could go wrong. Let's quickly look at your demand. And what I've got on the screen is I've got a triangle. Now these things relate to one another, where you've got real power. That's the kilowatts that you are busy drawing. And then you've got the reactive power, and the amount of reactive power, the result of the reactive power gives you your kVA. It works on the Pythagorean equation. So the kVA over there is equal to the square of the kilowatts added to the square of the kVAR. So let's assume that it's a weekend and you are drawing 140 kilowatts. Your system shows a demand of 190 kilowatts. So what I took was this actually comes out of your load profile. So it was a weekend load. Now, if I'm going to change the kilowatts at the bottom over here. So let's assume you've got 100 kilowatts that's busy being pushed into the grid by the solar system, which means it's going to reduce your real power over here to 40 kilowatts. So I'm going to assume that 100 kilowatts is being supplied by solar. That reduces your load from the grid to 40. Have a look at what happens to your kVA, because your kVAR, your reactive power component, is going to stay the same. It drops your kVA down to 136, which is not, I don't think it's significant. It's substantial, but it's not. From 190, look at the comparison between the kilowatts being drawn and the demand. So you go down from 140 to let's make it, you've got 120 kilowatts being provided by the solar system. So you're only drawing 20 kilowatts from the grid. Look at your demand. Your demand's still sitting at 132 kVA, even though you're only drawing 20 kilowatts from the grid. And that is because your reactive power component stays the same. Quickly before we go. So these are the graphs I drew, maybe a bit over the top. If I zoom out, so that's your reactive power for the entire year. In your municipal bill, they don't give reactive power. They give us a power factor, which is what I took, and they give us kVA. So I took the power factor and the kVA and I calculated the kilowatts. And then because I knew the kilowatts and the kVA, I could calculate the reactive power component. And that's what we've got over here. So if I zoom out a bit, that's for the entire year. So there we go. This line over here, this line represents 0.8. So if you have a power factor of 0.9, that is pretty adequate. If we add a line, so that line is 0.8. You can see over weekends, wherever the top line crosses the bottom line, it goes below 0.8 there. What's that? 0.64. So this is going to cause issues when you have a solar system installed. You can't just, you won't be able to have a solar system installed and have your demand side managed. So I would like to propose that you, in order to manage your risks, that you follow a tiered step approach. Because then you can spend, for this step over here, your control and your power quality, it's probably going to cost you about 300,000 Rand, maybe 400,000. The controller that we're talking about over here is about 200,000 Rand for the controller. You won't be able to do what you need to do for the 7,000 Rand. And the reason why you need to follow a tiered approach is so that you can manage your risks. You can take one step, make sure that it works, make sure that everything's aligned, make sure that you can see the savings, make sure that you can see the device that you've just paid for, that you can see it working, and you can see the impact it's having on your load profile. And then you tweak what the controller does to get it to align to what your business is busy doing. It is going to drive you insane if you have to try and do this while the solar guys are still trying to commission your installation and getting the batteries to work, getting the inverter to switch on, getting the EMS to do what it's supposed to be doing. And the issue is that this EMS is not going to do what you want it to do. So I've installed. You're welcome to have a look at my YouTube channel. Have a look at the kind of videos that I create. Have a look at the installations that I've done. There are some of the installations are featured on my YouTube videos where I address some of the issues experienced during installation. Have a look at those videos. Familiarize yourself with where you are heading with this solar journey. If the approach is the wrong way around, you're going to find yourself frustrated because the money that you are investing in this installation is not going to give you what you need. So what you need is a better quality controller. You need battery capacity with a higher C rating, and you need to understand what your battery payback is going to be in terms of rand per kilowatt hour. I think I've got a video on that somewhere. Alternatively, I'm happy to share some with you. And you want to be able to calculate your levelized cost of energy on your grid-tied solar system. For this, I definitely have a video in my YouTube because it was uploaded, I think, earlier this week. Take a few minutes, kindly consider what I've discussed over here. You're welcome to double check the facts and the figures with me. What would be next? I need to understand whether you'd be open to follow this approach. If you'd be open to follow this approach, we can set up a few meetings, maybe 2 meetings with guys who provide controllers, so that we can make sure that the guys that you are meeting with would be able to provide you with the right kind of controller for your environment. The controller that comes with any of the inverters are not going to be able to do what you want it to do, not in your factory setup, not in your environment. You have too many variables that you want to manage. You want to be sure that the next step you take is going to be able to provide you with something that's going to support your factory, support the processes, and be able to provide a bit more automation for what it is that you guys are busy doing. You look like the kind of guy that's extremely busy. I am going to end this video here. Thank you very much for your time. If you have watched through the entire video, that's amazing. I hope I have given you some food for thought. And I look forward to having another discussion where we can look at a bit more detail into what it is you need and what the best products would be for taking you further into your business and saving you some money.